Buongiorno baddies, welcome back to another bombastic video. Our only question today is how many positive integers less than 100 have reciprocals with terminating decimal representations? So it's important to point out here that, like I explained in a previous video, if we have a 1 over n always has to be to make it a terminating decimal or a finite decimal. It has to only have twos or fives, or both, in its prime factorization, and only twos, fives, or both. So that's important to point out when we're doing this problem. Let me just make this a little smaller to make myself have some space. So now that we know this information, we can start working on our categories. And what I mean by categories is sorting all the reciprocals into only twos, only fives, or both. And then everything else we can just discard because that's really the only information we need. So this is our only two category. This is our only fives category. Only fives. And this is our twos and fives category. So our only twos, one, since it's basically powers of 2, 1 is 2 to the power of 0, 2 is 2 to the power of 1, then we have 4, we have 8, 16, 32, and 64. Now we have to stop here since it said it was less than 100 because the next power of 2 after 64 would be 128. So now that we have our only twos, let's count how many we have. 1, 2, 3, 4, 5, 6, 7. That means that in this category, we have 7 numbers. Moving on to only fives is basically powers of 5 within 100. So 5, since it is 5 to the power of 1, technically 1 is 2, but we've already included it, so I will not include it again because that would be overlapping. 5 to the power of 2 is 25, but 5 to the power of 3 is 125, so it stops here. There are only two numbers that fits this category. Moving on to twos and fives. Since 2 and 5 make a power, it always makes a 10. These are always going to be 10's multiples. Since if you have at least 1 2 and at least 1 5, they're going to make 10, and everything beyond that is going to be a multiple of 10. So taking that in mind, our earliest one is 10 itself. Then we have 20. We skip the 30 because that includes a 3. 40, since it's 20 times 2, and it keeps the same basic prime factorization, just with an extra 2. 80 works as well. So does 50, since 50 is 5 and 10, and both of those are within it. So now that we have everything we have, so 10, 20, 40, 50, 80, 50, that is 5 numbers. So now we just add up all of the numbers that we got in each category, and we will get a good old, I'm going to do this in bubble letters because it looks cool. That is not a 4. We have a good old 14, and 14 is our final answer. So yeah, that's the end of this video. I hope you guys enjoyed, and I hope you guys learned something new, even though, I don't think many math contests would pop this kind of question, but it is kind of tricky. They might disguise it in a word problem. They're probably not going to give it to you outright. So yeah, that's the end of this video. I hope you guys enjoyed it, and I hope you guys learned something new, and I shall see you guys in the next one. Bye!